Please give it up for sin-ack.
Hi. Yeah, as Loris mentioned, I don't really like to use my real name, so you can call me sin-ack or Agni or whatever you prefer. I don't mind. Today, I want to talk, rather tell you a little story about the time I tried porting the Zig compiler to SerenityOS. So, I'm going to tell you a bit about what my motivation was to do this to begin with. And then I'm going to explain the steps I took to get the various parts of the compiler working. So the Zig CC, the C compiler, and then Zig itself working on SerenityOS. And I'm going to go through some of the details of the problems that I faced while I was doing this. And there were a lot of those problems. And I think we'll finally finish it off with some closing thoughts, some future work-related things, and maybe a little surprise. OK. So why port a new programming language compiler to a new operating system? Well, the first reason, and the obvious reason, is that it's fun to do so. Just, I'm sure many people in the audience have their own hobby projects, pet projects that they work on when they're not working or doing something else. And so do I. So I have a couple of projects that I'm involved in, a couple of projects I've created. And I find that it's hard to do the same project for a very long time for me. So if I get tired of the project that I'm currently working on, then I'll take a couple of weeks, go to some other project, and then do something else there. Maybe fix a bug, add a new feature, or port Zig to it, I guess. And then the second reason I wanted to port Zig to SerenityOS is that I wanted to see Zig Self working on it. So Zig Self is an implementation of this self-programming language. It's a very old programming language that I've been working on and off for the past year or so, and I wanted to see how it would fare on SerenityOS. Now, I've been using the word SerenityOS a lot, but how many people in the audience know what it is? So, can I count? Well, at least let this be a refresher for the people who do know what it is and new info to the people who don't. So SerenityOS is a hobby operating system developed by Andreas Kling. The project started in 2018 after Andreas got out of rehabilitation as a way to keep himself occupied during the new free time he had. And over time, the project grew to over like hundreds of contributors. Last I counted, it was something like 700. So in SerenityOS, everything is from scratch. So you got the kernel from scratch, the GUI layer, the core system utilities, the applications on the screen, an entire browser with its own JavaScript engine, small feat I know. Everything is from scratch. And the code base is extremely approachable because everything is in a single repo, which means that if you want to see how something works, you can actually grep through from the shell all the way to the kernel. You can just grep through the code and see what gets called, all the syscalls. Everything is within under your fingertips. And Andreas himself actually posts hacking videos about SerenityOS to his YouTube channel in a semi-regular basis, where he adds a new feature or fixes an issue with the system. And they're pretty entertaining and very educational at the same time if you want to start hacking on SerenityOS or any project, really. I first got interested in SerenityOS back in April 2021 when Andreas announced the Discord server he opened. So now, say what you want about Discord, but the new communication medium was certainly a great place to collaborate and work on various parts of the system. And I thought it was really engaging, and over time, I started contributing various fixes. Although I'm not as active a contributor anymore, real life kind of took over, and I've got some projects of my own. I still contribute from time to time, at least if I'm not contributing, it's still a great system to just pull the latest changes, compile the system, open it up in QEMU, and see what's changed. So back in February 2022, I wanted to see how my project Zig Self would run on SerenityOS. Well, only one problem. there is no zig target for SerenityOS. So I was officially yak baited. So what do you need in order to run zig binaries on an operating system? Well, the easy solution is to just write some target code and then run that target code, like run the compiler on your zig code and then take the binary and just run it on the system. But that's boring, right? So what I wanted to actually do was take zig itself, compile it for SerenityOS, and compile my project within SerenityOS. And this would actually help a lot with SerenityOS as well, because I would be able to contribute like any POSIX changes, any like bug fixes to SerenityOS itself. So it would be a net benefit for both projects, I thought. As most of you already know, Zig currently relies on LLVM for the actual binary generation in its default mode. This means that if you want to run Zig in an operating system and have it produce binaries, you're going to also need LLVM ported to that system too. This is certainly a barrier for entry for new operating systems who want to have Zig run on it. Also, side note that this requirement is going to go away in stage 2 with the self-hosted backends, but they're still not ready. Last I tried a couple of weeks ago, the x86-64 backend cannot compile my project yet, and back in February when I tried this, it was nowhere near to completion. Thanks to the work of Daniel Bertillon, Andrew Castor, and many other people, the hard part was already done for me. The LLVM compiler and rather the LLVM project and this Clang compiler already had ports to SerenityOS. So I already had that down. Probably without those, this would be a non-starter. But since the Clang port was already working, that meant the only thing I had to actually port was Zig itself. So what else do we need Zig on a target? Because we have LLVM, but what else does a Zig compiler need? Well, it needs a Zig compiler. Wait, what? So in order to compile Zig code for an appropriate target, you need a Zig compiler that can compile code for that target. And this is kind of a chicken and egg situation. In my situation, I had no chicken and no egg because, as far as I know, this is the first time that someone has tried porting Zig to Serenity. Thankfully, there is this one very useful project called Zig Bootstrap by Mr. Andrew Kelly himself. And what it does is that it builds a host LLVM and a host Zig, and then uses that host LLVM and host Zig to build a target LLVM and a target Zig, which allows you to build Zig from scratch just using a C++ compiler and the build tools. So that project became the basis of my efforts, and huge thanks to Andrew for it. Earlier, I mentioned that in order to build Zig binaries for a target, well, you need a Zig target. If you're using the LLVM backend, you're also going to need a matching target on the LLVM side. Since there was already a Clang port for SerenityOS, that meant that I already had the necessary patches in order to get, like, for example, LLVM or Clang to output binaries for SerenityOS, but I didn't want to write a whole bunch of target code on the Zig side and then just to see it not work at all. So what I wanted to do was, use one of Zig's killer features, which is the C++ compiler called ZigCC. And what I wanted to do is take ZigCC, like get ZigCC working for the host, and then make it compile a binary for SerenityOS, and then see if that runs. So if that runs and I'm able to like get some output out of it, that means that at least it is possible for the target Zig to be a valid SerenityOS binary. So my goals were as follows. So I would first build a host Zig that's capable of building files for Serenity, and build a simple C program to see whether it will work, and finally get to compiling Zig itself for the SerenityOS target once I confirm that C programs can be compiled. The first problem I hit was before I even started compiling, actually. Back in February, the LLVM patches that SerenityOS used to make the necessary changes to get Clang and stuff working were a single large patch meant to be applied to the LLVM monorepo. Well, Zig Bootstrap is not the LLVM monorepo. It has the various projects split out into different folders. And in fact, libcxs is within the Zig folder because it's bundled with the Zig compiler. So I wasn't able to patch the thing. Thankfully, Daniel quickly split up the patches for me. He maintains the Clang port he's a big contributor to it. So I was able to apply the patch in parts. Thanks, Daniel. Once that was done, the LLVM compilation was pretty uneventful, just a lot of waiting. Next up was compiling host Zig, and I hit a couple more issues. First up, Zig really doesn't like to be out of sync with LLVM's enums, and there are very static assertions within Zig LLVM.h that require you to be completely synchronized with the LLVM triple enums with the Zig LLVM enums. This is actually not a bad thing. It's a really nice thing because once you add the new operating system to the enum, you can go ahead and the compiler will tell you, okay, you missed Serenity in this switch case here, and you can just go through the entire compiler and add the new targets, make the necessary changes to match new targets requirements, and it's actually a really good thing. And of course, adding to the C++ part means that I also have to synchronize the Zig parts as well, because at the time, and today still, the Zig compiler is still a hybrid between the Bootstrap C++ code and the new self-hosted Zig code, which means that sometimes you have to do some manual synchronization in order to have everything working smoothly. And just adding Serenity to target OS tag, which makes Serenity a official Zig target, will just guide you through the compiler and make you add things wherever you need to. As part of the fix everything that the compiler complains about ordeal, I came across this bit of code. This code tells the Zig compiler about which C startup objects to link the executable library against when cross-compiling to a certain target. Now, in that part of code, there's a lot of details that nobody except those weird people who develop compilers need to know about. But the gist of it is that this is different for basically every operating system, and it actually varies across whether you're developing a library, a static executable, dynamic executable. It changes all the time. For SerenityOS, the CRT begin and CRT end stuff already seem to be handled automatically by the Clang driver. So all I really had to do was just copy something that looks similar and just replace the file names with the ones that I found in userlib once the system was compiled. And it seems to work, and I plan on not touching it ever again. So once all the compiler errors were fixed, I had the host Zig built and ready to build programs with. So I wrote a Hello World C program, pointed zigcc at it, and linker errors. Right, so in order to build a C binary that links to SerenityOS libc, we need to know what libc itself needs. At the time, this was fixed later, but at the time, libc was being linked statically against the compiled C binary, which meant that because static archives cannot declare their dependencies, you needed to just trial and error until things kind of just stopped complaining about. And in the end, I had to add libdl, libm, libopen, and pthreads for the C binary to link successfully. Oh, and libc++ too. Yeah, Serenity is fundamentally a C++ project, and it shows. The C standard library itself actually uses C++ runtime type info, and so you do need libc++ in order to link properly. It's unfortunate, but it works, so it's fine. And I should mention this. As of just a couple weeks ago, all of this stuff was vastly improved by Tim Schumacher, which I'm probably butchering, sorry. And all the various libraries were actually linked back into libc, so all those libraries I mentioned, which actually makes Serenity need the least amount of libc flags to link now. So thanks, Tim. OK, so the C binary built, and it looks like it's, well, C binary when I run file on it. So let's put it on the disk image and run it, and, well. So this is an issue with SerenityOS. Basically, when you load in a program, your program first has to load in userlibloader.so as its interpreter, which relocates your sections and then sets up all the various dynamic libraries that you use, and then passes control back to you. The problem is that the static pi binaries, which are static binaries that can be relocated, also need the relocation stuff, but they don't want to use the loader. And as Daniel put it, they're the edgy version of static binaries. Of course, what's the best way to make Zig output a dynamic binary while link a dynamic C++ library, I guess? That works. And after doing that, this beautiful command line generated this beautiful binary. And here's a Zig build C binary running on SerenityOS. Oh, and the proper fix for the dynamic binary thing was using the designated function for it in the Zig compiler, which I would learn and then promptly facepalm. OK, so we've confirmed that Zig can indeed build a binary that can work on SerenityOS. But we haven't actually built any Zig code. That was just like a hello world that I built in C and then compiled and put on the Serenity disk image. So what do we actually need to build Zig code in particular? Well, for things like printing to the screen or allocation of work, the built binary needs to know how to talk to the operating system. And there are two approaches in Zig that are used for this. The first approach is just to directly write the syscall mechanism, all the various syscall constants and everything directly into the Zig compiler. And this is the approach taken with the Linux target, because Linux has a syscall stability guarantee. And the second alternative, which is taken by basically everything else, is you call libc functions, and the libc function is called the syscalls because on most operating systems, such as macOS and Serenity, the libc is actually your stable syscall interface. So when the time came to build Zig for the SerenityOS target, I needed to tell the necessary things in our libc in order for the compilation to succeed. So here's a revised checklist. The three components that are of interest are zlib and llvm, which are just two C and C++ projects, respectively. And then we're going to build the target Zig, which is our final destination. Building zlib was mostly uneventful, save for a little hack needed at the time, because for some reason, some unrelocatable symbols just sneaked into the zlib archive, and you had to pass fpic to it. That's since been fixed in Serenity's Clang patches. And now it was time for target LLVM, but it wasn't as easy as it was for the host. First off, it couldn't find compressed2 from zlib, even though I just compiled it. Why would that happen? We had some brainstorming on Discord, and from Daniel's suggestion, I tried building with sin-ack find root path pointed to the out directory for the target, but it still didn't work. Or, well, it would have if I hadn't accidentally forgotten / on the line about that flag, so I love shells. OK, moving on. Now sin-ack can't figure out where dlopen and dladder are. This is just a repeat of the earlier, oh, you need all these libraries in order to link libc at all problem. So we just resolve by linking those libraries in the two. But beyond those minor setbacks, the zlib and llvm compilations for the target were rather easy. And now it was time for the fun part. And now we're at the final stage before we can start trying out Zig itself on SerenityOS. For the most part, this is just a variant of the thing I had to do with the host Zig, where I just put something in the enums, and then that complains about a whole bunch of stuff, and then I go and fix what the compiler complains about. So, but how do you actually add a new operating system to the Zik standard library? Earlier I mentioned that you either implement the syscalls directly or you go through libc. Since SerenityOS is stable, syscall interface libc, this means adding Serenity to this OS direct right here, right here at the bottom. And then once you do that, the Zik compiler will start annoying you about all these things that are missing in this new struct you just added. For an OS-specific struct in std.c, you're expected to just list all the various libc constants defined by POSIX and other libc stuff in various structs grouped by their prefix. So take prod, for example. Each of those are just like a single POSIX constant, and you just chop off the prefix and add it to a struct. So it looks nicer. And one notable exception to this is erno numbers, actually, which is an enum instead of a struct. Beyond this, you're also expected to declare a couple of functions, so to signal support for various things you have, such as like iteration of like shared objects for debugging support, and directory iteration and things like that. And you're basically just supplying information about your specific target. But there's one special definition that you must supply, and it is quite special indeed. And it's our girlfriend erno. Erno is a delightful legacy piece of POSIX. It's basically a global value that gets written to whenever something unexpected happens as a result of a libc function call. The problem is this obviously won't work when you have more than one thread, so you need to somehow keep each thread separate on what their erno value is. And the solution that most operating systems have come up with is making erno a thread local and then providing its location through a pointer by calling this erno location function. And most OS modules in std.c do this. But while erno was a thread local in SerenityOS, it was still a public symbol from libc, and there was no erno location. And I just created the dumbless implementation by just returning the address of erno itself in the beginning. But that still caused a weird zero-size TLS symbol. I have no idea why that happens still now. Which makes the dynamic loader crash, actually. So I just patched that, assert that, and it seems to work. And after this, since then, we've improved the SerenityOS libc side by actually making erno location the default way to get the pointer to the erno. And after all of that, and implementing a directory iterator and a couple of other things, we went through semantic analysis, and we're at link point, but you know better than to expect that it will link on first try, right? So of course we had linkers, but this time we were actually missing functions. So all right, we were missing POSIX functions actually. So let's implement them. Just put a bunch of stubs in libc. What could go wrong? Well, after this and chasing a few more bizarre loader-related errors, we finally got the Zik help printing. And while this is the Zik binary running, it's nowhere near actually running Zik itself because we're not actually compiling any Zik code. So let's build a hello world now. OK, so let's do Zik build exe. And OK, so I ran Zik build exe. It's taken a while, just blank command line. It's taken a good while. It doesn't seem like it's starting. OK, so let's see what it's doing. OK, so those are POSIX semaphores, so I guess those are broken. Let's make the target Zik build in single-threaded mode per Andrew's suggestion. At this point, someone had pinged Andrew, and he was in the chat. So, And once I did that, it seems like we were no longer stuck there. And as a small side note, it seems like building the Zig compiler single thread is actually currently broken in stage 2. I'm not sure why that happens, but or well, we were going to get somewhere, but that's where my earlier decisions bite me. Turns out those functions as I stubbed were actually needed. Who could have thunk? So let's implement them really quickly at 1 a.m. In the kernel. While I was doing so, I hit this interesting error, which is apparently a first. So, so since SerenityOS didn't have an actual way to get the clock resolution, I wrote the best implementation possible. So anyway, most of the work here was implementing a few more of those add functions, so not much to say here. And now I'm getting this weird crash in init, which is in C++ code in the Bootstrap compiler. Not sure what that's about. And the fun part of this specific crash is that if I add any debug prints, change any location of any of the debug prints, or change the arguments of any of the debug prints, the crash location changes. So that's fun. So at this point, it was very late at the night to be debugging weird crashes. So I came back the next day and continued debugging. And this was mostly a matter of just adding a bunch of debug prints and seeing what happens. So that went on for a while until I hit a very peculiar error. So ignore the silly debug messages. At this point, I was pretty bored. The interesting part is that randomly, instead of printing the silly debug message, we're printing this huge string. And this string is actually a string defined right at the start of the init function called target-specific features. And a bit more debug prints, and it seemed like we were crashing. We were getting this weird behavior right after calling stage 2 version. So what's special about stage 2 version? Well, as I mentioned earlier, the Zig compiler is still a hybrid of C++ and Zig, but this doesn't just mean that Zig code calls into C++ code. No, it means that C++ code can call back into Zig code, which is helpful for deduplication. But to facilitate this, there are a bunch of function declarations in C++ code, and the code on the Zig side is set to the C calling convention. But what happens if the C calling convention doesn't exactly match between C++ and Zig? Well, unfortunately, you don't get nice compiler errors this time. You get that weirdness. OK, so in order to test what's actually supposed to be generated, I wrote the stage 2 version function in C++ and compiled it for Serenity. And here's what that looks like. So it's doing a bunch of pushes, and then it's doing a bunch of moves, and then it's returning the value. And here's the version that Zig builds. Looks different. So after posting this on Discord and getting the help of a couple of C++ wizards, I learned that, well, thou shalt not pass structs through registers, at least on x86. So the system v APIs for x86 is clear on this. So at any point that you're returning a struct, you're supposed to take the pointer and then write values directly to the value, rather the address given to you, and then return it in EAX. And doesn't matter if it's like a single value struct, doesn't matter if it's an empty struct or whatever. It has to always be like through writing to an address, and this is apparently called an SRET. So I didn't know enough about the Zig compiler to fix this properly, but my fix, which consisted of adding like an x86 check to an x86 64 function, and that seemed to work. And we're finally getting some compilers on the Zig side on Serenity. OK, So now that the Zig compiler was working, the only things I needed to fix were those errors reported by the compiler. And I had to implement various things that I skipped out on, such as the f-access at syscall and actual debugging support. And I also had to stub out flock because we didn't support file lock downgrading. By the way, Andrew, I have news for you because you had like a feature request back in February about like atomic flock downgrading. And we do have that in SerenityOS now. Yeah. And finally, I had to tell Zig about our libc location because that mechanism was not properly implemented yet. And well, with all of that, we have a Zig binary running on SerenityOS. Though only with the compiler built on release mode, debug mode was called in an integer overflow, but details. Now that I was able to run a basic Zig program, I wanted to see if I could complete my original goal of running Zig self on SerenityOS 2. And this actually helped me catch a couple of using U size interchangeably with U64 bugs. So like not respecting the target size. But eventually that worked too. So here's a Zig self REPL running on SerenityOS. And after all of this, these changes, unfortunately, were not upstream into the Zig compiler, and there is no currently Zig port for SerenityOS. The main reason is that at the time, stage 2 was very close. Yeah, right. And also, due to the various things I had to hack or patch around in SerenityOS, it was just too much. And since I had to do all of the work again for stage 2 anyway, I just gave up on it. But I had always planned to complete it once stage 2 is officially ready for use. So in the past few months, thanks to the tremendous work by the Zig team and all the contributors' help, stage 2 became the default compiler. So where does that leave us? Well, I have something to show you. So let me switch over to here. And is that the correct command? Yes, I think so.
Can you increase the font size?
Oh, sure. This part doesn't matter.
Oh.
Okay.
This part matters.
Oh, no. OK, there we go. And let me see if I can increase the DPI on this. Or maybe I shouldn't just not touch this because it kind of breaks if you blow on it. So let me see if I can full screen that with like a zoom to fit. Yeah. Oh, there you go. OK, so this is SerenityOS, and thanks to the work of all the people I mentioned earlier in this talk, and the SerenityOS POSIX compatibility and porting situation is in a much better place than where it was back in February. So I have this folder in my home called Zig. What could that be? And in fact, if I run that binary, you will see after a brief moment, because the file system driver is kind of slow, that it is the Zig compiler. And if I run it with version, you'll see that it's a pretty recent version. OK, so I can actually go ahead and compile some stuff. So like I have this small test program that I have here, which just prints hello world. And I can just go ahead and this is actually harder than it looks. OK, and that should, within a couple of seconds, do its thing. And there you go. Yeah. And this build of Zig is not just useful for building just basic versions, basic programs. So let me just go into Zig self here, and let me get rid of my cache and my out. And I can actually go ahead and compile Zig self, which was my project to work on SerenityOS. it just takes a little bit to warm up.
Is this upstream?
Not yet.
Is it?
I'm going to get to that. I'm going to get to that. So let's just wait for the LLVM. Wait, is this the build script or the final object? Oh, we're going to have to wait longer. Yeah, because that was the Zig build itself being compiled. Hey, it kind of works like a script, so. And this is actually stage 1 too, since I don't know, LLVM is broken on stage 2 for this project. I don't know why.
The old terminal size problem.
Well, you should blame Ali for that.
Who?
The shell guy on SerenityOS.
No, this is a problem with every terminal on every
Yeah.
operating
Oh, there you go. And I can now. And there you go. And I can. And things do seem to work. OK. So, well, to change something in the Zig compiler now, I would have to turn off the virtual machine, go back to the host system, edit the Zig compiler, and then build it, and then copy it to the disk image again. But that's annoying. So let me just go into here and do this and do that. And let's wait for that. Or let's not wait for that. That takes like 10 minutes. But this is actually the Zig compiler itself being built with the Zig compiler on SerenityOS. And originally, this was supposed to crash when it got to some point like LLVM emit object. I had this whole spiel about, oh, we need to do more stuff in SerenityOS. But while I was sitting here, it just kind of somehow compiled. I have no idea why. And there's actually something in out directory, but unfortunately, when I run it, whoops, let me just get over here. If I run it, you will see that it unfortunately does not work yet. And crash. Too bad. Well, we can always improve things, so this is fine. So, what's next? Feature work. So obviously, I want to get this upstream, but and make it as simple as possible to just go into the port zig directory in SerenityOS and just writing package.sh and just waiting for it to compile. But there are some steps. That we have to take before we can get there. So the first thing that we have to do is upstream our LLVM patches. So because currently SerenityOS LLVM on SerenityOS is facilitated by having patches applied to the LLVM source code, and this does work for our use case. But in order for the Zig patches to be upstreamed, because previously, when it was back in February, when stage 1 was a thing, I could just if-def out the Serenity part, and that would just remove all the Serenity-related references if I wanted like a symbol. But now that some of the LLVM linking and emitting code is in stage 2 too, I can't just if-def out like the enum value from the Zig side. So these LLVM patches do have to get upstreamed before we can do any Zig upstreaming. So once LLVM patches are upstreamed, I want to find a solution to the problem of SerenityOS being too unstable for Zig upstreaming to properly happen. So the names of POSIX symbols are the same, but they can change, and they can change very often. In particular, the erno is just a enum, like a sorted enum, and you can just add a value in the middle, and suddenly your Zig binary doesn't work anymore. And we did some brainstorming in the Serenity Discord, and what we came up with was having a small, like a script sort of thing in Zig, and use Zig C import superpowers in order to import all the libc headers from SerenityOS, and then take all those constants, write them out to like a zig file, and then put that file in while we're compiling zig. While these struct definitions and other things come from, those are upstream because those are relatively stable. The stuff like constants are coming in from the SerenityOS side while we're compiling the port. So I think that could be a viable approach to get the zig side upstreamed. And after doing both of those, I want to explore how we could provide access to SerenityOS from zig. So I want to see like if I can pop up a libgui window from zig, for example. That's not as easy because I would have to write bindings because libgui isn't all in C++, but maybe there's an alternative by parsing IPC files and replacing those C++ types with zig types, and maybe there is a way that we could communicate with the Windows server that way. I want to finish up with some thoughts, kind of tie back into the cycle thing. So obviously the story I told you and the effort I put in is nowhere near the scale of zig or SerenityOS, either of those projects. But I believe it captures at least a little bit of that go and do spirit. Because at the start of this project, I thought that, no, there's no way that you can run zig on SerenityOS. It's going to take weeks, I thought. And it turns out it took like 3 days. And it turns out the reason nobody ran zig on SerenityOS is just nobody wanted to do so. So if there's a moral to this story, it's that any task is achievable. Be it an operating system, a new programming language, and a new browser from scratch, anything is possible with enough yak shaving, one yak at a time. So I would like to thank all the people on the slide for their help along the journey, and especially Daniel Bertolan, Ali Mohammed, and Andrew Castor for emotional support during the final hours of the port, and Andres Kling for creating the amazing SerenityOS project, and Andrew Kelly for creating the wonderful zig programming language. Thanks, everyone.